So to talk about the binomial theorem, we first have to talk about what a binomial is. And a binomial is an expression that involves the sum, or difference, it's the same, of two unlike terms, right? So for example, 3x plus 5x is not a binomial because that's just 7x. But 3x plus 2, that's a binomial. They're unlike terms. Now, what we're going to talk about today is a way to expand these binomials when they're raised to different exponents. So for example, this one you all know very, very well, right? This is a squared plus 2ab plus b squared, right? You've known this forever, but what if, it's a plus b to the power of 3 or 4 or 5 or 6 or 7, right? Well, that's what we're going to talk about today. So take a look here, right? Take a look here. This shows what we call this a squared plus 2ab plus b squared. We call this the expansion of a plus b to the power of 2. Okay? Okay. So what you're given here is a plus b raised to different integer exponents. So raised to the 0, 1, 2, 3, 4. Now, anything to the power of 0 is 1. But if you look at the actual expansion, it's, to the power of 0, it's 1 times a to the 0, b to the 0. Now, a plus b to the 1 is just a plus b. Right? And if you look here, a to the 1, that's a, plus b to the 1, that's b, right? This is a very complicated way of just writing a plus b. A plus b squared, this is how you know this formula. A squared, b to the 0 is 1. A to the 1, b to the 1. So plus 2ab plus b squared. Do you see how this is a squared plus 2ab plus b squared? But now, let's take a look at what patterns we see here. In the first case, the exponent here is 0. And what's the sum of these exponents in that term? 0. Take a look at this one, a plus b squared. What's the sum of the exponents in each term? 2. Do you see that? Yeah. Let's take a look at this one, 5. What's the sum of each of the exponents in each term? What's the sum of the exponents? 5. Do you see that? Okay, let's take a look at some further patterns. Let's take a look at just the exponents of 5. It goes from a to the 5, 4, 3, 2, 1, 0. So it starts from this exponent here at the front, and then so it's a to the 5, a to the 4, 3, 2, 1, 0. And then b starts at 0 and then increases 1, 2, 3, 4, 5 to this number. So do you see that pattern over there? And then we've got these red coefficients in here. And that's what we're going to talk about in a little bit. So let's summarize some of these patterns. Each expansion has n minus 1 terms. N is the exponent. Okay? So if n is 0, you have 0 plus 1 term. For n equals 2, how many terms do you have? 3. Okay? The first and last terms are always a to the n and b to the n. Okay? The sum of the exponents is always n. Now, the powers of a decrease from n. The powers of b increase to n. Now, look at the coefficients in each row. Do you see how they're symmetric? 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1, right? It's symmetric. Okay, now, let's talk about the coefficients. The coefficients come from Pascal's triangle, right? These are called the binomial coefficients because they are the coefficients of the terms when you expand a binomial. They can be arranged in triangular form, and we call that Pascal's triangle. Each term in the triangle is the sum of the two numbers above it. So for example, you have, the first one is 1. Then you have 1, 1. Okay, that's a given. Now, you always start with a 1. And then for the next one, you're going to take the sum of two numbers right above it. So 2, 1. Okay, then I put a 1. The next one is going to be the sum of the two numbers above it. 2 plus 1 is 3. The next one, 2 plus 1 is 3. Okay? All right? So this first row is n equals 0. Then this is the row for n equals 1, n equals 2, n equals 3, and so on. Okay, so let's try. So this is n equals 4, 5, 6. This is n equals 7. Why don't we write the numbers for n equals 8? So look, you start with the 1. Now what's the next number going to be? 7. What's the next one? 21. And then 35. 35 again. 21. 7, 1. You see that? So if you're ever bored, just get a piece of paper and you can do like 70 lines of this. Right? Hey, what are you doing? Pascal's triangle. Oh. Good old Pascal. He was also French, Blaise Pascal. He's also credited with, he has a unit of pressure. Yeah. How many atmospheres is a Pascal? How many atmospheres is a Pascal? And then 1,000 pascals is a kilopascal. Right? Okay. All right, so we're going to use Pascal's triangle to expand each binomial. So take a look. This is n equals 5, right? So, you know, so if I were to like do this on a quiz, so it's 1, 1, 1, 2, 1, 1, 3, 3, 1. So this is n equals 1, 2, 3, 4 right now. 1, 4, 6, 4, 1. Yeah? How many is this? 1, 2, 0, 1, sorry, you start from 0. 1, 2, 3, 4. We got to go one more. Okay, so those are the ones here. Okay? All right, so let's figure out which one is A and which one is B. So this is A, and the 2 is B. So those are going to be the coefficients, 1, 5, 10, 10, 5, 1. So I go 1, and then it's 3x to the power of 5, 2 to the 0, plus the next one is, so what I also like to do is I just write the coefficients first, right? So the next coefficient is going to be 5 plus 10 plus 10, right? You can also do that, right? Just fill them in. And now it's going to be 3x to the 4, 2 to the 1, 3x cubed, 2 to the 2, 3x squared, 2 to the 3, 3x to the 1, 2 to the 4, 3x to the 0, how much? 2 to the 5. So at each step, the coefficients add up, the exponents add up to 5. And now you have to simplify this. So 5 cubed, 243x to the 5. And then it's plus 5 times 81x to the 4 times 2 plus 10 times 27 times 4x cubed. Yeah, 3 to the 4. Plus 10 times 9 times 8x squared. 5 times 3 times 16x plus 32. So at the end of the day, this is 243x to the 5, 810x to the 4, 1080 x to the 3, 720x squared, 240x plus 32. Okay, and I notice here my second example is covered by that box somehow. But I did want to do another example. Yeah, we might just do that. Why don't we solve B over here, like in the page previous? Okay. It's x minus 2y to the power of 6. So B, we're going to go over here, is x minus 2y to the power of 6. Okay, so what's the, what are the coefficients going to be? I'll just add it here, right? So 1, 6, 15, 20, 15, 6, 1. Okay. So again, I'm just going to write them here. So 1 plus 6, 15, 20, 15, 6, 1. Okay? You don't have to do it this way. I like to just so I can like focus on everything else. So what's A here and what's B? A is x and what's B? Negative 2y. Okay? Because it's A plus B, so it's A plus negative 2y. So we're going to go with, okay, so here's another way you can do it. X to the 6, x to the 5, x to the 4, 3, 2, 1, 0. And then it's negative 2y to the 0, 1, 2, 3, 4, 5, 6. Honestly, however you want to do it, right? I trust you at this point. And then all we have to do is, figure out what the coefficients are. So this is equal to x to the 6 minus, okay, so let's take a look for a minute here at what's going to happen. Do you see how you have one of your terms is negative, right? And that negative term is raised to positive and odd and even exponents. Whenever the exponent of the negative term is odd, it's going to be negative, then positive, then negative, then positive. So this is going to have alternating sign. Okay? So minus 12x to the 5 plus 12x to the 5 times y plus 60 x to the 4y squared minus 160 x cubed y cubed plus 240 x squared y to the 4th minus 192 xy to the 5th plus 64 y to the 6th. Okay? And that 14 is just, okay? Right? Yeah.
Where did you get that where 6 became 12 became
So it's 6 times negative 2 to the 1 is negative 12. 15 times negative 2 to the 4 is, okay? So do you see this? Like, so you can just do x minus 2y to the power of 6 in one shot, whereas before you would have maybe had to do like squared, 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 and multiply them, right? I mean, it was like this long process, and you had to memorize these random formulas for the a plus b cubed. But do you see how there is like a lovely pattern, right? And you can do it like this. Now, this is fantastic. This Pascal's triangle, I mean, it's really fantastic, right? But do you see how it could also have some downsides? Because if this was to the power of 18, then you really do have to spend time going all the way to the 18th number here. Whereas you're like, you know what, maybe there is another way. And it turns out there is another way. So if we look at, so first of all, let's look at these exponents for a minute. All right? So let's look at these exponents for a minute. Here, let me go to this one. So in this one, n equals 5. Yes? So this number here is n, right? It starts with n. Okay, now, what if we could come up with a different way? What if we could come up with a different counting variable? All right. What if we had another counter called r? Okay. And suppose r went from 0 to n. Okay. Look at what's happening here. Let's call all of these r, right? R is 0, r is 1, r is 2, r is 3, right? So this is r is 0, r is 1, r is 2, r is 3, and so on, right? And so if this is r, but it's like counting up, right? Then how can I write these numbers? It's just n minus r every single time. Is that right? Okay. So, and here too, that's n minus r. So I can totally, since there's one index that's, you know, going from 0, 1, 2, 3, 4, I could write a little sigma notation for that, right? Yeah. Okay. So now let's talk about the binomial theorem. Oh, I know what I meant. I meant to just delete that box altogether because I rewrote it here. Okay. So yeah, it's this. I wrote the same thing here in better terms, in like a bigger way. So the binomial coefficients of this can be generated in a different way. Okay. So each of this term, so let's say you want to find the coefficient of this one term, right? A specific term. It's given by this formula. Okay? Now, I know you haven't really seen this formula before, but look at this. This is it comes from like statistics, right?
Yeah, actually.
Yep. So this is, when you talk about permutations and combinations, this is a combination. So it's all of the different combinations of the two numbers n and r. Okay, so n goes here. That's the exponent. Okay, so this is n, the exponent. All right. And r just goes from 0 to n. Okay, now the formula for it is this, n factorial. Do you guys remember what factorial was? So if I have 3 factorial, that's not just 3, like it's not an excited 3. That's not what we mean. It's not an exclamation point. It's 3 times 2 times 1. So whatever that number is factorial, you multiply that number with all of the other integers that come before it until 1. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 and so on. Okay? So this is the formula that we use to come up with with each of the terms. So for example, CNR, it will be n factorial, whatever that number is, then n minus r, so the sum of these two factorial, and then this little one factorial. So for example, if I had C5, I don't know, 2, okay? That would be, this is n, this is r. So it would be n factorial, 5 factorial, over, what's 5 minus 2? 3 factorial, times the other number factorial. So the first one factorial over the difference factorial times the second one factorial.
Wow, that's more factorial.
Okay? All right, so with that, that's how we can also, that's another way to come up with these coefficients. So each one is C, 3, 0, 3, 1, 3, 2, 3, 3. Okay? So we're going to do that manually. So here we go. Let's do a plus b cubed. Okay, so here's what we do. You write down C. First you put in n, that's 3. And then this number r starts from 0. R is always going to go from 0 to n. And then the term inside is the same thing as before. So it's going to be a cubed b to the 0 plus C3, 1, a squared b to the 1 plus C3, 2. So do you see how the 3 is always staying the same and then the 2 is just increasing? A cubed b, no, sorry, ab squared plus C3, 3. So what happens is that's when you know how to stop. When these two are the same number. C3, 3, a to the 0, b cubed. Now, yeah.
Do we never adjust, we only move the r?
Yeah, n is constant. So let's do each of these now. C3, 0. The first number, factorial. Now subtract them, 0 factorial. The second number factorial. So this is a cubed. Plus 3 factorial over, subtract them, 2, and then the second number. Are you seeing the pattern there? A squared, yes. No. I'll tell you right now. A squared times b. Plus, what is the fraction going to be here? What over what? 3 factorial over what? 1 factorial. AB squared plus 3 factorial over 0 factorial, 3 factorial, b cubed. Now, a factorial, 3 factorial, is also how many different ways there are to arrange 3 different things. Okay? So if you have 3 students here, how many different ways I have to arrange these 3 students in these 3 seats? And there are 6 different ways, 3 times 2 times 1. If you have 0 objects, how many different ways are there to arrange 0 objects? 1. There's 1 way. You just have nothing. You just have an empty box. That's why 0 factorial is always 1. So this is just going to be a 1, a cubed, plus, okay, what's 3 factorial? 6 over 2, that's just 3, a squared b, plus 3 factorial is 6 over 2, 3, ab squared, plus, how much is that? Just 1, b cubed. So there you have it. Okay? No. Let's do some practice with this. Maybe I can do it here. Suppose I have, I don't know, 7 factorial over 4 factorial, 3 factorial. Okay? Look, there's a really cool way to do this. This is 7 times 6 times 5 times 4 factorial, right? Because it's 4 times 3 times 2 times 1, right? So it's 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 3 times 2 times 1. So look, all of these cancel with these. Okay? So these factorials always cancel with each other. Yeah.
Are we going to have a calculator section?
Yeah.
Yeah.
Yeah. So what else cancels here? What else cancels here? The 6 with this 6, so this is just 7.
Wow, 7 times 5.
Oh, times 5, 35. Whew. Okay? All right. Well, it turns out you can also do it with your calculator.
I like this. Much better.
No. So let's go ahead and there is a button for it on your calculator. Okay. So take a look at this term, right? You see this one, 3C1, it's this one for which we got a 3, right? So here's what you do. You go to, where did it go? So slow. Okay. Okay, so you go to menu. Probability is number 5. And you're not going to do factorial, even though that's what you want to do. You're going to press number 3, combinations. All right, and it gives you this symbol. Now you type in 3, comma, where's the comma? Here, under the pi, 1. Enter, 3. Okay? So this one here that I did before, right? This one is actually C, 7, and 3. Okay? So let's see if it's going to give us a 35. So menu, 5, 3. So it's 7, comma 3. Yay! Okay? All right. And yes, there is an option here that just says random, right? Because every calculator needs a random button, right? So there you go. That's the random button. Okay. All right. Now, why is this helpful? Because look at this one. Find the coefficient, just the coefficient of the indicator term in each expansion. So I have a minus b to the power of 10. This has 11 terms. I want just the coefficient of the 4th term, right? I mean, it's too long to do the whole Pascal's triangle and expand it, and this gives us a way to do it immediately. Okay, so if it's the 4th term, how much is r? R goes from 0, 1, 2, 3, 4. So the 4th term has r equal to what?
3.
Ah, 3. This is the 4th term. Yeah. Okay, so the 4th term means r is equal to 3. Okay, so you're just going to do 4 minus 1 equals 3. So n is equal to 10, r is equal to 3, n minus r is equal to 7. You need those three things. Okay?
Why do you need n minus r?
I'll tell you. Because what did we say before? Each of the terms is r and n minus r for their exponents. Okay, they add up to n together. Okay, so the format is this: C, N, R, A, I'm yelling because it's so exciting, N minus R, B to the R. So this is going to be C, 10, 3, A, 7, B, how much? 3. Oh, but what is B in this case? It's actually negative B. 3. All right, I know I'm right. But, you know. So let's do the combination of 10 and 3. So combinations, 10, comma 3, 120. A to the 7 times negative b cubed, right? So this is negative 120 a to the 7b cubed. It means the coefficient is how much? Negative 120.
Okay, that's why.
Yeah.
So you have to understand just see turns negative or not.
Yeah. And then, and also if it was, let's say, like x plus 2y, then you'll also have like 2 to the power of 3, so you'll have like a different number. Okay, like this one here. Now we want the coefficient of the x to the 7y term. Now this is, you're given this question in a different way. When you have this, you already know that this is n minus r, and this 1 here is r. Okay? So, for each of these, I need these 3 quantities. N minus r, I know is 7. R is 1. So what's n? 8. Okay? So it's C, N, R, A, N minus R, B to the R. Okay, so C, 8, 1. A to the N minus R. What's A? 3x to the 7, negative 4y to the, what is it? It was R1. Okay? So can somebody tell me what combination is here? We call this 8 choose 1, by the way. That's the lingo. 8 choose 1. What is it? 8.
If there's ever a 1, is it just the other number?
Yeah. Okay, and then it's going to be times 3 to the 7 times negative 4, x to the 7y. So altogether that's negative 69,984 x to the 7y. So the coefficient is this.
How do you know if it becomes positive or negative?
Well, I also just like did it here because it was negative 4 to the 1. Yeah.
Okay. But if it was negative 42.
Right. Correct.
16.
Yep. Okay, now this one we're going to expand using the binomial theorem. Okay? So, here's how you can do it without, writing too much. Okay, so it's C, 5, 0. Okay? 2t to the 5, 3u to the 0. So then it's C, 5, 1, C, 5, 2, C, 5, 3, C, 5, 4, 5. Okay? All right, and 2t to the 4 cubed squared 1 0, and then it's 3u to the 1 2 3 4 5. Okay? All right, these you're going to do with your calculator. So look, another easy way to do it. Once you've done one, you can just go up, up, press up twice, highlight, enter, and then you could just modify these things, right? Especially, like, so this is 5, 0, okay? And then look, if I'm going to do it again, especially if it's the same n, I could just change this one number. You see that? Okay, so you already know. Okay, let's stop for a minute. What's the first coefficient going to be always? 1. And the second one, it's going to be right, okay? And then, so you can do the other ones. But also, take a look. It's also symmetric, right? So after this, the coefficients are going to like symmetrically repeat. So for example, this is a 5. I'm sorry, 1, 5. What's this next coefficient? 10. Okay, and then after that, they're just going to repeat in reverse order, 10, 5, 1. Right, so you don't have to type it in every single time. Am I making sense? Okay, so now it's times 32t to the 5. Okay, 2 to the 5. So here it's 2 to the 4, 16 times 3, t to the 4, u. And then 8 times 9, t cubed u squared. 4 times 27, t squared u. 2 times, what's 3 to the 4 these days? 81, t u to the 4. And then 3 to the 5 is 243, u to the 5. So 32t to the 5, 240 t to the 4u, 720 t cubed u squared, 810 plus 243 u to the 5. Okay, and that is the binomial expansion of that one. Did I? 1, 2, 3, 4, 5. Oh, which one did I skip? Okay. 32, 240, 720. Oh, yes, because the numbers were all the same. Thank you. So this is, whoops, sorry. After the 720, we have 1080 t squared u cubed, 810 t u to the 4, 243 u to the 5th. Okay,